All right, so moving on to number 11. Leo Forrest is a keen golfer and would like to improve the distances he achieves with his tee shots. In a bid to improve his tee shot distance, Leo hires a golf coach. He records the distances and yards of his tee shots both before and after coaching, with the results shown in the table below. Leo is interested to see whether the mean distance of his tee shots after coaching has increased or not, and decides to use a t-test at the 5% significance level to compare the means of his tee shot distances before and after coaching. All right, A. Write down an assumption about the distribution of the data so that a t-test can be conducted. All right, there are 3 assumptions that must be made. All right, one of them is independence of observations. Right, so one of his tee shots didn't have anything to do with the other, which is a logical assumption to make. The other one is that they should be normally distributed. All right, and the last one is that they have equal variances. All right, or standard deviations. If you said that, that's similar. All right, you only had to name one of these. It said an assumption, so any one of these works. All right, you didn't have to have all 3, just any one of them. Okay, so B1. State the null hypothesis. All right, so the null hypothesis is that mean tee shot is the same before and after coaching. All right, B2 says state whether this is a one-tailed or two-tailed test. All right, this is a one-tailed test. Oops. Which is all you had to put. All right, basically, if you have mu1 is less than or greater than mu2, all right, that's one-tailed. If you have mu1 is not equal to mu2, all right, that's two-tailed. All right, in this case, he's specifically checking if his driving distance is greater after the coaching. So that would be mu1 less than mu2. All right, so that's a one-tailed. All right, C. Perform a t-test, writing down the p-value for the test. All right, so what we have to do here first is go to our lists and enter the data. All right, I already have all of the data in here. So here's all of my tee shots before coaching, and here's all of the tee shots after coaching. So then we just go to our stat and tests menu. We go down to a 2-sample t-test. All right, we have the data, all right, and we're using list 1 and list 2. There's no frequency lists here. All right, as we said, we think that the mean distance before is less than the mean distance after, so that's what we want. We always pool our data, all right, and we calculate here. So our p-value 0.0122 to 3 sig figs. 0.0122 is the p-value. right? Do remember that when you're doing sig figs, zeros at the beginning do not count. All right, so that's why we had to go out here. All right, D, justify your decision. What conclusion should Leo draw about the mean of his tee shot distances before and after coaching? Basically, since p-value is less than the significance level, all right, we reject the null hypothesis. Oops. All right, that basically means within the context of the problem that his driving distance increased after coaching. Right. Of course, you could say that significantly better, but just for terms of writing all this out and for time, that's it. All right. What I had specifically, which would be a lot more detailed, since the p-value 0.0122 is less than the significance level of 0.05, we can reject the null hypothesis. Thus, his mean driving distance is longer after coaching. All right, so next problem, number 12. A new spotlight is being installed on a theater lighting rig. The lighting crew must adjust the angle of the beam and mark out where actors can stand to ensure they are properly lit. The spotlight is located at point A, directly above point D at the front of the stage. The area covered by the light is shown by the shaded region, enclosed by triangle ABC in the following diagram, and can be adjusted by changing the angle CAB. And of course, they give you a nice diagram there. The lighting crew have adjusted the light so that the distance from A to B is 10 meters, the distance from A to C is 8 meters, and the length of the stage floor covered between points B and C is 5.2 meters. All right, A, find the angle the lighting crew have adjusted the CAB to. All right, so they give you all of the sides of the triangle. All right, so, and they, of course, were looking for angle CAB, they call it, which is really angle A, all right, the angle from the spotlight. All right, so we're actually going to use the law of cosines, that the cosine of A is equal to b squared plus c squared minus a squared all over 2bc. All right, now the A has to be the side across from the angle that we're looking for. All right, so in this case, the side across from angle A is 5.2. All right, and then of course, B can be 8 and C can be 10. Now, of course, we're going to have to take the inverse cosine of both sides eventually anyway, so we might as well just kind of do that all in one fell swoop. All right, so this is going to be 8 squared plus 10 squared minus 5.2 squared all over 2 times 8 times 10. All right, you plug that into your calculator, and you should get 31.1 degrees when rounded to 3 sig figs. All right, B. All right, some information before B. It says point C is 1.2 meters from the front of the stage at point D. To ensure actors know where to stop when walking towards point B, from the direction of point C, the lighting crew mark a point on the floor at which any actor under 1.9 meters tall can stand and remain fully lit. Find the furthest distance from the front of the stage that the lighting crew should place their mark. Okay, so the original triangle kind of looked something like this. All right, but we now want to use this right triangle here. All right, so they tell us we knew that this was 5.2. All All right, and they then tell us here that this is 1.2. All right, we know this is 10. All right, and we're also looking like have to add this kind of point here. All right, we're kind of looking for this spot here. This is what we're looking for, where somebody 1.9 meters tall, right, this distance here, to be 1.9 meters where they can still stay fully lit. All right, so I know that this piece right here is 1.9. All right, so first I'm actually going to find this whole distance here, all right, simply by using the Pythagorean theorem. All right, so a squared plus b squared equals c squared. So my a squared, 1.2 plus 5.2 would be 6.4. So a squared plus b squared, which I don't know, is equal to c squared, which is 10. All right, so I simply subtract 6.4 squared and then take the square root of that, and I get that b is equal to 7.68 374 9085. All right, now of course I only care really about this part of the right triangle. All right, this small piece, because that'll give me this distance here that I want. So I need to subtract the 1.9 from that. And when I do, we get 5.78 3749085. All right, so this piece now is this 5.78 ... Okay. So now, all right, if you think about these two triangles, the whole big triangle here, all right, and then the smaller triangle on top, all right, because obviously they're both right triangles, all right, and then this angle here is the same, all right, and then two parallel lines cut by a transversal, these two angles are the same. That means these are similar triangles, which means they're proportionate, right? So this side of the small triangle compared to this side of the big triangle has to be the same as this side of the small triangle is to this side of the big triangle. So we're actually going to set up a proportion, right? So we're going to say 5.783 ... All right, over this whole big piece, which we know is this up here. So 7.683 ... All right, has to be equal to this piece, which is what I'm looking for, that distance, all right, over this whole big piece here, which we know is 6.4. So now I just essentially multiply both sides by 6.4, and when I do that, I get the distance is equal to 4.817 439 ... All right, which to 3 sig figs, we can just say 4.82 meters. All right, so you put the little X, the little sticker, 4.82 meters from the front of the stage. Right, and that would tell us where they could stand and still be lit up. Okay. Number 13. All right, the following diagram shows a part of the graph, g of x, all right, which is equal to the quantity 2 minus x times the quantity 3x plus 9. All right, where x is all real numbers, all right, and the kind of thing that they give us here kind of looks like this, all right, and they shade in this area here. Again, just refer to the actual paper here. All right, so it says find the area, or for A, it says write down an integral, all right, for the area of the shaded region R. So I'm going to have an integral. All right, now I'm going to have to pick from where to where, all right, but it's just going to be of my function, and then with a dx here at the end. All right, so I need to know from here to here. All right, well, this is obviously 0. That's my origin right there, right? So 0 is going to be here. All right, so I need to figure out this. Well, this is one of my x-intercepts. If I just set each of these pieces equal to 0 and solve, I get x equals 2 and x equals -3. So this has to be -3. So there's my integral. All right, then part B just says find the area of the shaded region. So we literally just plug this into our calculator, right? We can hit math 9 for the integral of -3 to 0, right, of 2 minus x times 3x plus 9. And of course, that's dx. And that is 40.5. All right, and that's just unit squared. They don't really give us units here, so we'll just say general units. All right, then it says the 3 points, A, 0, 0, B, 3A, and C, 15, 0, define 3 vertices of a triangle. All right, so they give us some triangle here. All right, so we have our x and y axis here. All right, and they give us some triangle, all right, that looks something like this. All right, and they call this A, B, and C. All right, of course we know this is 0, 0, this is 3A, and this is 15, 0. Right, so 15, 0, and this is 3, comma A. Okay, so then it says find the value of A, the y-coordinate of B, so I'm looking for the y-coordinate of B here, such that the area of the triangle is twice the area of region R. So I know the area of a triangle, right, is 1/2 base times height. All right, well, they just told us that the area has to be twice of this area. So 40.5 times 2 is 81, and that equals 1/2 times the base. Well, from 0 to 15 is 15. Oops, 15. All right, times the height. All right, well, the height of the triangle is actually what we're looking for, this A, right? That's the y-coordinate of point B here. So all I have to do is solve this equation. All right, this is 7.5, right? So just divide both sides by 7.5, and you get that h is equal to 10.8 to 3 sig figs. And that is it for number 13. All right, last but not least, number 14. All right, and they give us a table here. All right, and they say, okay, this is the number on the sector of a little spinning wheel, and this is the probability. All right, and they say, okay, the probability of getting a 0 is 6 out of 20. All right, the probability of getting a 1 is P. The probability of getting a 2, oh, whoops, there's 2 1s on there, I guess. So the probability of getting another 1 is 3 over 20. All right, the probability of getting a 2 is 5 over 20. All right, the probability of getting a 3 is 3 over 20. And the probability of getting a 5 is 5 over 20. All right. So it says that Leonardo has constructed a biased spinner with 6 sectors labeled 0, 1, 1, 2, 3, and 5. And here are the probabilities of those. All right, part A says, what is the probability? So find the exact value of P, which is the probability of getting this other one. All right. Well, in something like this, all of our probabilities have to add to 1. So 6 plus 3 is 9, 14, 17. Wait, no, I'm sorry. 9, 14, 17, 22. That's not possible. Oh, I'm sorry. This is a 1. I'm an idiot. All right. So we have 9, 10, 18. So all of these combined are 18 out of 20. Well, if they all have to add to 1, this has to be 2 over 20. All right, so that's it there. All right. Then it says Leonardo is playing a game with his biased spinner. The score for the game is the number which the spinner lands on after being spun. Leonardo plays the game once. All right. B says calculate the expected score. All right. So the expected score, all right, the expected value here, the expected S, all right, is simply the value of that the spinner lands on times its probability, and you add all of those together. This formula is actually in your formula packet. So you would have 0 times 6 over 20 plus 1 times 2 over 20 plus 1 times 3 over 20, all right, plus 2 times 5 over 20 plus 3 times 3 over 20 plus 5 times 1 over 20. All right. I won't write all of those down, but you simply plug that into your calculator and you get 1.45 as the expected value. All right, part C. All right, Leonardo plays the game twice and adds the two scores together. All right, so now he's playing it twice and adding the two scores together. All right, find the probability that Leonardo has a total score of 2. All right, so there's 3 different ways that he can do this. All right, he can get a 0 first and then a 2. All right, I guess I should make that a and. All right, so that would be the probability of getting a 0 is 6 over 20. All right, and the probability of getting a 2 is 5 over 20. All right, or so you would add the probability of getting a 2 and a 0. All right, well, that's the same thing, just switched around, right? So probability of getting a 2 is 5 over 20, and the probability of getting a 0 is 6 over 20. All right, plus the probability of getting a 1 and a 1. All right, well, the probability of getting a 1, all right, is actually, we have 2 1s on there. One's 2 out of 20 and one's 3 out of 20. So that's actually a total of 5 out of 20. And then, of course, getting a 1 again would be 5 out of 20. So you add all of these things up, all right, 6 out of 20 times 5 out of 20, plus 5 out of 20 times 6 out of 20, plus 5 out of 20 times 5 out of 20. All right, so this is 30 over 400 plus 30 over 400 plus 25 over 400. That's going to be 85 over 400. All right. Of course, I guess for explanation purposes, right, this would be 30 over 400 plus 30 over 400 plus 25 over 400. That equals 85 over 400. Of course, you could reduce it if you want to, but you do not have to in IB. And that is it for this practice test 1.